We're keeping it practical with our next speaker. He's ready to show us the ins and outs of backdooring DVRs and NVR devices. Arun Mane is a security researcher at TUV Rhineland and a DefCamp regular by now, and you're about to see why. Arun, please join us on stage. Let's give him a big round of applause.
Okay, I'm really sorry about the slides miss. Bună Romanian. So I'm trying to speak in Romanian language. Okay, I'm a security researcher in TU Rhineland. My mostly works lies in IoT, ICS, some vehicle and telco products. Telco products like fleet management systems and other stuff. I am a trainer as well. I do practical ICS hacking, those kind of trainings I conduct. I'm going to start that vehicle security as well, that training. And I'm speaker and the trainer for various conferences like DefCamp itself, and Nullcon, Black Hat, DefCon, and a lot of stuff. And yes, I'm part-time DJ actually. So I do DJ when I get free time. So there is one disclaimer. So stay away from these guys, actually. It's Palinka and Absinthe and this guy, actually, Philip. So if you're in Romania, please stay away from these guys, actually. Yeah. uh, Agenda, we'll understand what exactly the DVR and how embedded systems are in a world, in the market, electronics market. And we'll see ugly side of the hardware, actually, and also understand the hardware implant. This is the main talk for the backdooring those devices and future roadmap. So if you see the IoT statistics from 2015, and they also mention the 2025. So it goes from lower to high, and we are expecting something like $75.44 billion in the future, actually. So if you're talking about IoT, that means we are talking about the hardware, embedded systems, right? So I'm talking about only IoT. There are some like car manufacturers, they use ECUs, infotainment systems, and other stuff. So as per this previous statistics, so we conclude that there are too many vendors in the market. They create their own innovations. They modify, they put something facilities in IoT systems or other embedded systems to work properly. So they are in a hurry to launch their product in the market. So due to this problem, they are not considering hardware security prospect. So in terms of hardware as well as the external communications like web applications and other stuff, Wi-Fi, Bluetooth, or other Zigbee. So that results in botnets. Botnets like a Mirai. So if you see the Mirai, it's a remotely controlled device which has more than 60 common passwords. And when it hits to any router or DVR or something, say they flash the firmware and they put it their backdoors inside. So this is for they use for DOS attack, and in 2016. I think so in 2017, they released their entire code on GitHub. And after that, they introduced other Mirai botnets variants like Satori, Masuda, and Pure Masuda. So these are the Japanese term, actually, and they have different names. So Masuda is like a master. So it's a Pure Master and Master. These are the variants of Mirai botnet. So what if you're trying to do pen testing about the hardware like CCTV or other hardware like DVR, NVR, and other IoT devices? You'll find most of the bugs like firmware vulnerabilities, default credentials, access to shadow files, or any password files inside, and you'll get the password for default password as well as backdoor password. So if you reverse engineer properly, so you'll get some the backdoor links as well. About the web applications, so if you know the OAP's top 10 web application vulnerabilities, so all vulnerabilities you can see in the except SQL injection. Sometimes it works, sometimes it doesn't work. So in mobile application, there is again top 10 mobile applications, OAP's top 10 mobile application vulnerabilities. So in terms of iOS and the Android, you will get all the vulnerabilities over there. So external communication, may device comes with BLE, that is Bluetooth Low Energy, Wi-Fi, Zigbee, other things, LoRa, a lot of stuffs. So if you're talking about BLE, there are different kind of vulnerabilities, like you can replay relay attacks or other more. You can modify some GATT protocols, and Wi-Fi, you can jam it, or other DAuth, or rather you can crack the passwords as well. And Zigbee, yes, relay and replay attacks can work, and even you can forge entire packets. So what exactly the DVR? DVR is nothing but digital video recorder. So it records the video in digital format, like from USB or the USB flash drive, SD memory, or other any hard drive, and it records through the analog cameras, or rather you can say the coax-based cameras, coax wire cameras. And NVR is actually it's a network video recorder, not new. It's my mistake. So same, it records the video in digital format or the different kind of hard drives. Rather you can say SD flash or something, but it only records IP-based cameras over the Ethernet. So these are the big difference between the DVR and NVR. But the motivation behind these two devices to record entire videos and all stuff. So if you go for the common vulnerabilities for DVR and NVR, so you'll come to know the same default credential, backdoor credentials. We found some buffer overflow in web applications, like BOA is the embedded web server applications, and application vulnerability like CSRF, cross-site scripting, authentication bypass, that you can do. So if you go for those things, so you will find a lot of references where you can see these kind of articles, and same they referred firmware analysis, firmware reverse engineering in that case, web application and other stuffs. But no one mentioned about the hardware actually. So so we need to talk about the ugly side of the hardware. So there are different methods to do hardware attacks, like through JTAG, through SPI, you can extract some data from the SPI or other I2C chip-based. Even in microcontroller, if it supports SWD ports. So there are some tools available in the market from the manufacturing sides. Other open source tools are there. So you can communicate over there, and you can extract and do some sort of reverse engineering. So I'm talking about the UART. UART, there are two types of methods you can do it. Like one is a manual method. So manual method, like if you have microcontroller and if you access the data sheet of particular microcontroller, you will come to know the pin numbers. So which one, UART works on RX and TX. So you need to find out RX and TX and ground. So once you know the exact pin on the microcontroller, you can use DMM like a digital multimeter. So you need to do some conductivity test on the ground, and for the meter voltage test on the RX and TX, and we'll come to know which one is RX and which one is TX. So for that purpose, we need to use DMM in that case, and USB to serial converter. It's for when you going to access the UART port, and yes, pair of eyes. So without eyes, you can't do it. So after that, there is another way. It's automated way. Like you can use JTagulator, and yes, the JTagulator, or other you can say JTag enum. So JTagulator is a commercial thing, not exactly the commercial. It's open source as well. You can make it yourself. Other you can Otherwise, you can buy from Adafruit or the other vendors which gives which provides a JTagulator. So another is a JTag enum. It's a open source, a completely open source. You can have the codes, and you can flash it on Arduino Uno, and you can find the UART ports as well. But I'm sorry. So this is for JTag enum is for JTagulator. So JTag enum is for Arduino Uno, and JTagulator is supports JTag as well as UART. So in that case, UART, you'll find some RxTX and ground pins. So credit goes to Joe Grant. He invented this JTagulator piece. So after doing some hunting with the manual and automated, we found two UART interface on the DVR actually, and one for the debugging purpose, and another is for monitoring purpose, log monitor. You can see the log monitors, what's going on over there. But facts are different actually. So we found UART with credential access, which is not monitoring purpose, and another is without credential, which gives a root access. So that means if you know the RxTX ground, and if you connect with USB to TTL converter, or other Shikra is another kind of tools, or other you can use Bus Pirate, or other FTDI chip, 232 chip. So you can, with the help of these tools, you can access a root. You can get the root access. So so hardware implant. So we found all vulnerabilities. This is the ugliest part of the hardware. So due to some market statistics. So what exactly the hardware implant? So 5 to 6 years ago, the NSA ANT catalog leaked. So it's related to NSA guys. So they use a backdoor in the devices to control systems, monitor systems, and all stuff, to extract information as well. And based on the leak, some very well-known researchers come up with some idea. They call it as NSA Placeit. So they created some small devices which can put on the extra hardware, and you can get the access remotely. Rather, it supports Wi-Fi, GSM, and a lot of stuff. So the Michael Osman is a great researcher. He introduced this platform, NSA Placeit. And this is the link. You can see the nsaplaceit.org. So you will get the all the informations. So another interesting talk, which you can see in Hardware I/O, delivered by Joseph Fitzpatrick. So Joe actually introduced another way to how we can do some sort of hardware attack on the PLCs, on other other embedded systems to get root access. So this is a really interesting talk. You can go and see the talk over here, and here is the title name. And I'm really thanks to Joe for motivating me to research on hardware implants. So what is the hardware prototype as of now? So we are using tools like Raspberry Pi. It's very mostly common in a market nowadays. SIM808, this is the GSM module. So there are different kind of modules. It comes with a GSM, GPS, and Bluetooth integrated. And for that purpose, we need to have the SIM cards. And again, the USB TTL converter. You can use their GPIO pins on the Raspberry Pi. And we need a power source. It may be from external. It may be from the DVR or other NVR device. And header pins to solder those kind of interface pad to put the jumper cables. And the soldering machine. So this is how my prototype. I have Raspberry Pi, and we have Shikra, and this is the GSM model. This is a really cheap one. So you can get it in 12 euros 12 euros. But if you're going for a good one, so the expense goes increase actually. So it's from 25 euro to 40 euros, and which gives 3G and 4G model also. But for prototype purpose, I use those devices, and the total cost of these devices comes in 30 euros. So it's really a good one actually. So instead of Shikra, you can use USB to TTL converter, or rather you can use the GPIO pin over here, RX and TX, and to communicate here, or rather from to communicate DVRs as well. So there are the 2-3 options over here. So intentionally I use Shikra because while doing some work, so I messed with some voltage and my GPI was not working that time. So I use a different path actually. So it looks big. So if you put something like this is the Raspberry Pi, and below the Raspberry Pi there is a GSM module, and this is the thing. So there are some in the market. There are the hardwares available for the GSM module as well, which comes in very small. And if you're using Raspberry Pi, again it comes in very small. So the vendor cannot check what exactly, not vendor actually, no, customer cannot check the what exactly the hardware, and is it a part of hardware or something else. So that's what you can do. So here I created all the setup. So our hardware implant have different kind of facilities, like you can track the device. So let's consider I'm the bad actor. So I want to do some hardware implant. So what I will do, I will buy the device, I do some modification inside, and I put it on eBay. So there are some people, there are some companies literally goes for to buy those the CCTV cameras or DVR, or rather you can say NVR. And once they connect, once they power on, then my script will work actually. So this is what I made some script inside over the you can say the Raspberry Pi OS, and it shows all the latitudes, altitudes, latitudes, and it send me the message on my mobile, and the entire locations. So I will show you the demo as well. And for that purpose, I created cron. First, I created a bash script which executes every time. There are different way to execute, but I prefer this style actually. So in a cron tab, you can send the message. You can execute these scripts like per minute, per 5 minutes, 30 minutes, 1 day or something like that. So then after that, you will get something, the message. So it's demo time. So I have video. So this is my mobile, and this is the same GSM module, and this is beside this Raspberry Pi. So it's trying to send the message. We got the message. When we click, you will get the link over here. So if you open the link on the mobile, so you will get the exact coordinates. So where that particular devices resides. So this is how we can do some sort of kind of attack, the scripting. So you will get exact location over here. This is my home actually. So once we get the exact coordinates, so after in the coordinates, we'll get the exact location. Either you can, if you're using 3G and 4G, so you can directly send commands to the, you can get the access on the Raspberry Pi, and from Raspberry Pi, you can send the commands to over the UARTs, and you will get the root access. Or rather, if you're using GSM, it's really difficult to get access over the GSM data, actually. So there is a possibility you can create a hotspot on the Raspberry Pi. So you need to go that particular location, and there are some conditions. So mainly that CCTV cameras lies on the entrance building, the entrance of buildings over there, and most of the times. And once you reach over there, and you will get the Wi-Fi hotspot, which is created by the uh, the Raspberry Pi, and show you the demo. So here I'm using my laptop, and I'm trying to search for the hotspot. So let's say it's a DefCamp 2018. So I will connect with my laptop, because we have a AP over there. So it's get connected. I can use Linux as well for that purpose. So if you're using Windows, you can use PuTTY. And I know the particular IP address of Raspberry Pi. So it will be 192.168.4.1. So once you'll get into the Raspberry Pi, and you can put the credentials. So once you put the credentials, you will get the access over there. I'm really sorry for my video recording. It's shaking. So yes, so you'll get root access over here. And if you do LS USB, you will come to know the what kind of devices are attached over there. So over here, you can see. Oh, sorry. Okay. So after LS USB, you'll get the list. Over here, a future technology, it's FT232H over here. So this is our Shikra in that case. And that means our device is connected with our Raspberry Pi. And after we need to find the port communication port number. In that case, it's USB 0. In my case, so you'll see the USB 0 over here. There are other types as well, USB 1, because I connected GSM module as well. So it's using a USB 1. So I'm using PicoCom. You can use Minicom as well in that case. So PicoCom, and my baud rate is 115.200. It's a default baud rate. So if you want to find another baud rate, so you can use baudrate.py, that really good script, and you will come to know what kind of baud rate the device is using. So after mentioning the baud rate, I'm mentioning my COM interface, like Dev TTY USB 0. Oh, okay, I was using USB 1. Okay, we got serial terminal, and you'll get the shell access direct from there. And if you press LS, and you'll get the list of everything. And if you go to the etc and the password file, we'll come to know that. And this is, we got the root shell over here. I'm really sorry to for the video style actually. So etc password passwd. So you will get hash, entire hash, and if you do some passwd dot dash, you will get the default the credentials. So over here, you will find same thing if you reverse engineer the entire firmware, so you will get same credentials. So what we can learn from there? So here you can, if your machine is that particular device is connected with a different thing, and someone changed their IP address, someone changed their the credentials, but you will get the credential from shadow files and other stuff like passwd and passwd dash. So there is another, you can escalate this process to different way as well. So there are different kind of possibilities that yes, you can possibilities like in the terms of power supply. So either you can go for the cells, or rather you can say power bank, which is not suitable at all. So there are some you need to find those kind of pins. This particular pins is for using for fan. So you need to create in such a way that you can connect to directly to your Raspberry Pi, and from Raspberry Pi it gives the voltage to the your GSM model or a 3G 4G model. And this is how you can do, you can power off those things. For UART, you can use GPIO UART, then USB to TTL converter. If you are managed to use both way, like with the GPIO, there is no need to use USB TTL. And you can use Raspberry Raspberry modules. They called it a Raspberry Hat, and it comes with a very small, and you can use for Raspberry Pi Zero as well. So the entire chipset looks very small, and if you use a PCB board, and if you modify the entire PCB board and just put it on the PCB board in different way, so it looks like the part of the PCB board of DVR and NVR. So future roadmap, yes, I'm going to create a custom PCB boards to create those kind of the backdoors or other implants. It will be a plug and play. You need to plug it and just leave it, and it can work like tools as well. So why we are talking about hardware implants? There are different ways to use in the hardware implants, like when you're doing some kind of pen testing. So you can, when you're getting physical access, so the root access, they said you require physical access for that purpose. So you can say that you can create a hardware implant and we can access from anywhere. So other things, you can use it in red teaming. So it's really a crucial way, but yes, it can be used for red teaming, that hardware implant attacks. And yes, for research purpose, you can go for hardware implant as well. So any questions? Yes. Okay.
Just a second, the mic is coming to you, right over there.
And again, I forgot to mention one thing. Actually, if you have a root access, so you can disable some sort of a lot of process which is running in the particular shell. It's like HDMI drivers they are working on. You can stop it, so no one can see that particular videos. Or rather, you can say you can disable entire web application. Again, there is a possibility no one can see the web applications interface over the HTTP. So there are different ways to, attack with the help of.
I have.
Over
Hello.
you.
Hello. I have two questions for you. First, how much time you need to hack
Where are you
hardware?
actually?
If you could just rise
Okay.
when you ask the question, so didn't. Okay.
Okay. Yes, yeah.
How much time you need to hack hardware?
It depends on the vulnerability actually. Sometimes, it gives the credentials. With credential, in that case, you need to perform fault glitching, or rather you can say side channel analysis. So these kind of products. So it will take some time. So if it is without credential, I think so it's enough for 2 hours actually. It's mainly 1 to 2 hours you can get the root access.
Okay.
So there are different way to get access on the UART, as well as sometime you need to use JTAG if it is available over there, and if the JTAG is enabled, so you need to do some sort of kernel patching over there, which can gives rather you can patch the credential over the UART, so it will gives the root access. So for that purpose, again, takes maybe 2 or 3 days.
Oh, nice. Second question, how do you automate hardware testing?
Automate hardware testing? Yes. So same thing, you can use Raspberry Pi and with the scripting Python, so you can yes, it's you can use Raspberry Pi and with a different kind of hardware, and you can plug it, and if you write the script in a Python, so you will get what kind of UART devices over there, UART interface, JTAG interface, but it's a little cumbersome because if you're going for JTAG, you need to use different kind of the tools. Maybe it's open source or other proprietary one. So it's depend case to case.
Okay, thank you.
Yep.
Okay, we had that question over here as well.
So hello, you showed us the future idea that you will be trying to power the devices from the fan connector.
Yes.
I don't know if you are aware of how this actually works, because this is not that you will be able to pull 5 or 12 volts from it, and at maximum, if you are lucky, you will have 200 milliamps. If the Raspberry Pi starts in emergency mode, it will be extremely unstable.
Yes, that's true. That's true. That's definitely true. So there is another way you can do the USB, female USB, USB Type A, so which has the data as well as the power cable. So anyhow, you need to manage over there. So how that is the main important. Yes, and sometimes the NVR they use SMPS. So in that case, there is a possibility you can you need to modify entire stuff for that purpose.
Yes, but if the power will be controlled with the on frequency basis, you will have a lot of problems.
Yes, that's true.
Okay, that's it. Thank you.
Yeah.
Hi, thank you for the presentation. I wanted to ask, you mentioned at some point you are using the GSM connection basically to reach out to the device, but do you think that in most deployments, I know it's not good practice, but probably in most deployments, these devices have internet access? Not accessible from the internet, but they have internet access.
Depends.
So in that case, could you like set up an encrypted tunnel and then exfiltrate data directly, or set up a reverse shell directly to your, and access the device directly?
Yes. That is another way you can say actually. But in a hardware implant, the concept for hardware implant is to have a different hardware which attached to that particular JTAG or the UART, and from that hardware you will get some the connection. But this is the another way you can say. Yeah.
Thank you.
Hey, hello. Given this is a hardware implant after all,
Yeah.
have you thought about if it gets found out in some way about encrypting it or using some kind of secure boot trusted platform module or something like that? How would that go?
Yeah, so there are possibilities. This is for like So some low enterprise kind of, the industries, if you're going for big companies, so they never buy from other vendors. So in that case, for that small scale industries, yes, they can buy from the eBay and which is cheapest one. Yeah. So in that case, yes, there are some. There is a possibility that these devices cannot access. Only things is, as per my testing experience, like most of the 80% from China vendors, from Chinese vendors, they are using one platform only. That only one firmwares. You will get same credentials over there. They will get the same PCB architecture. They use same microcontroller and everything. So there is a possibility if you'll get the hands-on on one device, and if you do some research about the companies, which companies can use same architecture, so there is a possibility you can put. But this is for not high-end one devices.
Okay, we have time for more questions, so keep your hands up if you have more. Out there in the back, is that a question or? I guess not. I guess not. Okay. I actually have a question, if you'll take it. So what would be your, let's say, biggest concern regarding IoT privacy? What do you think would make like the biggest impact? What is one thing that could help in the industry or beyond?
Yes, I will give you answer in different way actually. So recently on Bloomberg, they said it, the Chinese vendor put something, the backdoors on the RAM or other devices. So as per that conclusion, yes, there is a huge impact on electronics or other embedded world. So for that purpose, there are some process that you can follow. First, you need to vendor should test with a security perspective, like hardware testing, web applications, and other stuff, even in external communications. So then, if it is the secure, then you can go for to purchase those kind of devices. But there is really difficult to get information whether these devices are compliant with security testing or not. But it's a huge impact actually on the world.
That is true, and it's even more difficult for end users to figure out what's what.
Yes.
Okay, thank you so much, Arun.
Thank you.
Lovely having you here.